Hello, everybody. Welcome in this fourth class of our open course on groundwater modeling using MODFLOW and Model Muse with Saul Montoya from HatariLabs. Last time we have learned how to make our first model, and today we are going to make it a bit more complex even to see how we can model a bit more. So I'm very curious. I'm not going to hold you up more. Please use the chat if you have questions for Saul. He will regularly look at it. And introduce yourself and your country in the chat so we know who's here in the virtual world with us. And enjoy the course. Saul, the floor is yours.
Okay, really thank you, Hans, and I will share my screen as well to start working. Okay, so far I think that this is it, and let me check the chat. Okay, I hope that you have downloaded the material for today. 21 people online, so yeah, it's as I told you, Hans, it's an exponential pattern. Okay, let's see. Let's go. Okay, so here what we are going to do today is, give me 1 second. First, we start with the steady model. We are going to do a steady model. Most of the exercise, I mean, what it will bring you success on your groundwater modeling is practicing. Okay, so you are not required to do it. How to say, everything like tomorrow. You are not. I mean, if you are learning MODFLOW, please keep the idea that if you want to do regional modeling, stochastic modeling, machine learning in the water modeling, or this will come with time. I mean, you have to do a first good and simple model, and then go on with the complexities to other to, and then you will increase complexities. Be patient. And as I told you, be patient, be always open-minded, and it means groundwater modeling means a lot of work, but it will give you a lot of rewards in your life if you really like it. And trust in yourself. This is all. This is such it's really important because you have to deal with the code. Okay, you have to deal with the code, and then you have to be really trust. You have to trust on yourself because you are going to face a lot of challenge. Okay, so let's see. So I have here. We are going to do a steady model. Okay, for today. And okay, so let's start a model muse. Model muse. Okay, so let's start a new MODFLOW model. Next, new MODFLOW model. We are going to work with meters and seconds. Okay. That's it. Next. And here we are going to work with 3 layers. We are going to work with 11 rows, 8 columns, 3 layers. The column width, it will be 150, and the row width will be 200. Model top 0. And bottom elevations will be -20, -25, -35. Okay, and this will be aquifer 1, aquifer 2, and aquifer 3. Okay, so that's it. 8, 11, 11 rows, 8, 3 layer, aquifer 1, model top 0. Yeah, if you are here with me, please type yes 1. Today we have students from Chile, Saudi Arabia, Netherlands, Tanzania, Syria, Sweden, Portugal, India, Congo, Ethiopia, mostly India, more from India, Nigeria, Kenya, Indonesia. Okay, so it will be my challenge in life to know and to visit at least half of the countries that I have mentioned. Okay, so finish. Okay, so this is our model, and then you will tell me, hey, I don't think nothing has happened. Why? Because you have to send them. Here with this, you send. Okay? Yep. Okay, so this is our model. It's pretty simple model. We are going to review we are going to work with on a steady state, and our time unit will be seconds. So let's go here, model flow time, model flow time, and here we have -1 to 0 steady state. Okay, so just to review that, because we have to be sure that we are going to work on a steady state, and our model will last just 1 second, that will go from -1 to 0. Okay, this is just a review because those are the default parameters. Okay, okay, great. Okay, yeah, but okay, what we are going to do now is that we are going to shift. Okay, we are going to shift because this model is on MODFLOW 2005. Okay, yeah, you can do that while you are working with the model. I mean, so far your model doesn't break. Okay, but however, yeah, well, it is intended that you can do it 1 or maybe 2 times, but do not, I mean, it's not really a good practice to be like jumping in between MODFLOW versions. Okay, so if you go to model selection and then you go to MODFLOW 2005, automatically this great software will keep with the geometry, but will allow you to work in MODFLOW 2005. Okay, so everybody go in model selection MODFLOW 2005. You won't see any further change, but you have already changed of version. If you are here with me, type yes 1, yes 2. There is a question that say, what is depend on what, which are the criteria for the model, for the for the width selection? Is it it has two main, I told that on this course, it has two main reasons. The first is to have an adequate resolution on of your heads and of your drop-downs, and the second is to have an adequate, not to work with this with big amount of cells. Okay, yeah. Why 2005? That's really a good question, because we are going to work with the confinement conditions on MODFLOW 2005 for this exercise, because the confinement conditions for MODFLOW 6 are different, and I told that in another, there is a tutorial on that, okay? Ready? Okay, great, so let's go where we are going. Let's go here to model, and then, no, to model, and then layer groups, model, layer groups. And here on layer groups, because we are in MODFLOW 2005, we can set these to convertible, while the aquifer 2 and the aquifer 3 will be confined, okay? So with that, we are going to work with convertible, and this will be confined, okay? Great. If you are here with me, type yes 3. Okay, great. So just type okay. Okay, and let's go follow the tutorial. Okay, so we have to use hydraulic conductivity. So we have different horizontal and vertical hydraulic conductivities. Okay, so we can do it by objects. Okay, but we can do as well. We can do it by with objects, or we can do it with a case layer. For our case, it will be faster with a case layer. Okay. Data, data sets, or let's do it by objects, because in order to show you the procedure and follow the content of the tutorial. Okay, so we are going to be in the first, for example, this is the first layer, second layer, third layer. So let's go to the first layer, and here by default is 2, because it will mean that it has 2 formulas for the zeta, for the set, for the elevation. Okay, so this in 2, and here on the first layer, and let's create a rectangle that covers the whole extension of our area. Okay, so this will cover the whole extension of our model. Okay, and will drop us this. Okay, and here we are going to give, let's see, K of aquifer 1, that is alluvial, and it will be from model 1 to aquifer 1 bottom. Set value of enclosed cells. We can change the color. Okay, and if you are here with me, type yes. Which number? Yes, 4. Let me say, can we select layer 1 as not simulated? I mean, really, you can select as the type of model that you want. I mean, really up to you. It really depends as well of what you want to model. Okay? And how do you conceptualize the groundwater flow system? Okay? Yeah. Okay, so what we are going to do next is we are going to data sets, and then here on required hydrology on kx, instead of being 110 to the minus 4, it will be 5.8 e to the minus 5. Okay, 5.8, no, 5.78 e to the minus 5. Okay, and ky will be kx divided by 5. Okay, so ky will be kx divided by 5. So you have kx of 5.78 e to the minus 5, and ky will be kx divided by 5. You are here with me? Yes, 5. Okay, you are doing amazing. Okay, so we have kx 5.78 a to the minus 5, and the ky is kx divided by 10, and the kv, yeah, on the vertical direction, it will be 1.16 e to the minus 5, okay, e to the minus 1. Okay, so this is the last 1.16, 1.16 and e to the minus 1. Okay, if you are okay, yeah. Okay, okay, great. So we are going to hide this one because why we are going to hide this one? Because somehow it will prevent us for doing or for selecting or for working with other rectangles that also cover the area of study, but for the second layer. So how we hide this? We do just click and then we type hide selected object. So we just have to do right click and type hide selected object. Okay, and then we go to the second layer. Okay, so I can do Control Z. So I do right click, hide selected object, and go to the second layer where I do another polygon, another rectangle, where I do another rectangle, and this other rectangle will be K of aquifer 2, and in this case will be confined. Confined, and it will be from aquifer 1 button to aquifer 2. You can change the color. You can change the color. And then, okay, so K2, because we are in the second layer, we are in the second layer. Here we are in the second layer, so that's why K2, and it goes from aquifer 1 button to aquifer 2 button. Okay, and also appears here in the cross section, it appears that this on the second layer. And here on the data sets required hydrology Kx, and here on Kx it is uh, 1.16 e to the minus 6. Ky is kx divided by 0.1, and the kv is 5. It is 5.78 a to the minus 7. Okay, so just to repeat, kx is 1.16 a to the minus 6. Ky is kx divided by 0.1, and kz is 5.78 and 78. 8 e to the minus 7. Okay, are very similar to the values that are on the manual, so please follow them as well. And if you are here with me, type yes. If you are here with me, type yes 6. Please, if you are here with me, type yes 6. Okay, once again, these are the values. Yeah, okay. And once again, we hide this. Why we hide it? Because it will prevent us from doing another rectangle. So hide selected object, hide selected objects. Okay, and then we go back to the bottom, and once we are on the bottom, we also select this. Okay, we are in the bottom layer. Please note that here we are on the bottom layer, and we select this. We select this, and here it will be K of the aquifer tree confined, and it will be from aquifer to bottom to aquifer tree bottom, and as well we have another color, any color. Okay, so okay, so please follow me till here. And then let's go to MODFLOW features. Now to data sets required hydrology, and then we say KX will be it will be 0.000115. Okay, K set will be Kx divided by 10, and K set will be 1.15 e to the minus 5. Okay, once again, Kx will be 1.15 e to the minus 5, Ky will be Kx divided by 10, and Kz will be K 1.15 10 to the minus 5. Okay, if you are here with me, type yes 7. Here we have 37 listeners to this emission on the fourth class. Seems to be a steady rate of followers. Okay, so here we have a different value for Kx, we have a different value for Ky, and we have a different value of Kz for every layer. Okay, let's type. Okay, and then let's go here to edit. No, to data, edit data sets. Edit data sets. And here we will go to hydrology, MODFLOW initial head. And because, okay, and this is something that I have to remember. Okay, because before we have worked with these ones, okay, and these are the default values, but you have created one rectangle for every layer of your model because you have already assigned another value. Okay, so this has a this has a logic. Okay, these are the default values, but if you define an object that defines a value, this value will will superimpose these default values. Okay, so as long as you have an object that will apply one value, the model will interpret the parameter defined on the object. Okay, have you understood this? Please, if you have understood this, type yes 8. Otherwise, I can repeat it. I can repeat. Okay, so that's why all of these values are no longer applied to the model because we have already objects that define the values, that define these values. Okay, so but in MODFLOW initial get we have to give MODFLOW a model top plus 2, model top plus 2. I mean, you are being such a great group. I mean, it's a pleasure to give a course to you because your advance is great. I mean, it's really aimed to do more complex things because some of the challenges that we encounter when we give courses is that we cannot achieve a same level of the people of the students in order to develop complex topics. Okay, so here we have MODFLOW initial head is model top plus 2. Okay, and it's model top with capital M, with capital T and underscore. I mean, if you are going to type it in another way, that won't work. Okay. Okay, yeah. Okay, so we have already model top plus 2 and then apply and then close, apply and close, apply and close. Then go in model, then go to MODFLOW package and programs. Then which is the next step? We are going to define our boundary conditions. So here in model, let's go to package and programs. Let's go to MODFLOW package and programs. And here, let's open our boundary conditions that we are going to work with the CHD, with the recharge, and with the well. Okay, CHD, recharge, and well. And here on well, we have to define that the recharge is in the top active cell. And what does it mean, the top active cell? And this is in the documentation. If you have infiltration and if your water level or if you have infiltration and the water level is in your second layer, so it means that the first layer is dry. But if you work with the top layer and then if you apply recharge and by somehow or the first layer is dry and the first wetted layer could be the second, the third, or the fourth, actually it won't apply recharge, okay? Because the first layer, as you say, the top layer is dry, and once it's dry, that it won't allow you to be recharged. That is why you can use the top active cell. And what is the top active cell? Means that if you have a recharge, and if your first layer is dry, and then if your second layer is dry, it will look for the first wetted layer and it will apply recharge to that. Okay, so in this case we are going to type top active cell. Okay, and then type OK. Okay, so constant head recharge and well, and here on recharge top active cell, if you are here with me, type yes9 and please tell me moist, which is the yes9, and uh, tell me if you are okay. Moist, tell me what we can do. Okay. Yeah. Okay, so once again we are going, I'm going to hide these ones. I'm going to hide this one, and then we are going to give our boundary condition. So here we are going to create a line that goes from this part to this part. Okay, from this to here. Okay. Okay. And this will be CHD North. Okay. Let's change color, and then, and this will be 1, and it will be on model top, because it will be applied here. Okay, so CHD North, we change color, and then we change the set formulas to 1, and let's type model top here. Okay. Okay, give you 26. Okay, then go to MODFLOW features, CHD, and here on CHD will be, let's activate the CHD, and it will be from -1 to 0, and here it will be, and the starting and the ending is the same because it will be model top +2, and this one will be model top +2. Okay. Okay, so here we are. Okay. And then there is a question of Bohin that says you have bottom layer active. Is that what it should be? Yes, the bottom active layer should be this. Yeah, so this will be model top plus 2. Okay. So as you say, here is our boundary condition. Then we are going to do a similar boundary condition here on the last row. Here on the last row, we are going to do a similar boundary condition. That will be CHD south. South, it will be from this, and it will be as well on model top. Okay, so it's the same as we have said before. However, here on MODFLOW features on the CHD will be -1 to 0, and it will be model top -2. Here will be model top -2. So, and the boundary conditions are related to the model top. So you will have boundary condition that is 2 meters above surface, and then here that is 2 meters below surface. Okay, if you are here with me, type yes. Okay, yes. Okay, right. So let's type okay. So you will have a regional flow that goes from here to here, and the difference on heads will be 4 meters because this is +2 and this is -2. Okay, great. So let's continue. Then we are going to locate. Then we are going to locate in the middle layer, in the second layer, okay? And then we are going to go to to the third layer, okay? You are going to go to the third layer, and then you are going to locate yourself in row 5, column 6, row 5, column 6 here. So let's go to the third layer. Here, go to the third layer, and then let's go to row 5, column 6. Okay? Great? Yes. And here, let's do a click here. Let's do a click here. And okay, so here this will be called well. It will be called from aquifer 2 bottom to aquifer 3 bottom. Yeah, we can change color as well. Okay, it is in our third layer. Okay, and here on MODFLOW features, let's go to well, because this is a well. This goes from -1 to 0. This one goes into pumping rate, and since it's pumping, it's minus 0.00138. 0.00138. If you are here with me, type yes 11. If you are here with me, please type yes 11. So it is on the aquifer 2 to the aquifer 3, we change color, we name it well, and -1 to 0, and this is the pumping rate, and this is indirect. If you are here with me, please type yes 11. Oh, you are doing amazing. I'll type OK. Let's go here to model and MODFLOW package and programs because let's go to model MODFLOW package and programs because I have to check something. We okay. Okay, following this manual, we are not going to work with the recharge. We are going to work with the river package. Okay, so we have already defined the CHD, the well, but according to the manual here in workflow package and programs, please change the recharge to the river because we are going to work with the river. Okay, so if you have done this, please type yes 12. If you have done this, please type yes 12. Because what we are going to set is the recharge. Okay. Okay, great. So what we are going to do is we are going to create a river. So from here, let's go from this one. Let's go from this one to this cell. Okay, from the remember that you only work on the intersected cell. Let's go from here to here. Yeah, and this will be called river. Let's change color. And this goes from this goes on the surface at model top. Okay. So let's go here to MODFLOW features, and on the river package, we are going to type -1 to 0, and on river stage, we are going to type this thing that you could see, and this is the right. Okay, and save. Okay, let's go here to the F formula. Let's go to the F, okay, because we are going to type this. You can look from this into the function because we are going to interpolate, and then here on GIS, no, on little mesh, no, pocket, no. Not. Fracture of object length that will go from model top plus 2 and here will be at a distance of 0.0125 inches. Model top minus 2 at a distance of 1. Okay, what is this? What is this? Okay. Okay. Something that allows this is from Model Muse, not from MODFLOW, is that you can create formulas, okay? And these formulas can be pretty complex, but they can be also very powerful. What they say? These ones does an interpolation and interpolates from different points along the path of the line, okay? Because you have defined the line from this vertex to this vertex, so this will be your 0, and this will be your 1, and say, okay, here on the fraction 0.015, it will be model top plus 2. And this is true because you have a constant head of model top plus 2. And here, where the line ends, it will be, or I mean, at 1, it will be model top minus 2. And that is true as well because here is the constant head of minus top minus 1. Okay, so this, I mean, you will find this option in object and interpolate here is in math. And since I don't want you to get lost, I will put that on the chat. And they say, it is possible to have a model top plus 2 in layer 3? Yes, it's possible. It's possible that you can define your boundary conditions on the layer 3, but it really depends on what you want to do. Okay, if you are here with me, yes, 13. It really, I mean, you are not, and as I told you, you are not constrained. You are not constrained by the software because the software can do a lot of things. You are constrained mostly of your knowledge of the groundwater system. Okay. Okay, who else is here with me? The formula is on the chat, so you can copy paste, and then if you copy paste, it will appear here, and this is compiled. Okay, I will wait for you. Okay, well, only 4 people say that. 5. Okay, so, and then the conductance will be 0.0015, and the river bottom is closely the same, but is 2 meters below. So that means that here it will be -4, and here will be model top. Okay, so this is the formula for the river bottom, because I mean the river bottom is at the bottom. So and then we say that it has a water height of 2 meters. So it will be model top at the first at this fraction, and it will be model top -4 at this fraction. This is also on the chat, so you don't have to worry too much. But if you can do it, okay? So this is the river bottom, and then this is the interpolated fraction. Yeah. So, and then you just type OK. Okay. I will give you 1 minute to save your project and run your project. Okay. So if you are able to save your project and run your project, type yes 14 because and then after 1 minute I will do it by my own. I mean, we are going to do all together. Okay. So if you can do it, save your project and run your project, just type yes 14. Otherwise, in 1 minute we can do it all together. If you can do it by your own, yes 14. Otherwise, you have still 30 more seconds to do it. Come on, surprise me. Give me hope. Nobody else can save your project and run your project. Come on, come on. 10 more seconds. Type yes, yes 14 if you have done it. Okay, great. So we have to save files, save. Where we are on to save? We are on day 4, and then we create our, it's always recommended exercise 1, and then it's always recommended to create a folder, okay, because MODFLOW will create a lot of files in this folder. So, and this will be model 1, exercise 1, model 1. Okay, so we have day 4, exercise 1, model 1. Run our project. Don't change the name of the NAM file. Save. And then you will have this. Then this is the kernel. These are some warnings, just some messenger reference data. And this is your model monitor that says that so far the percent discrepancy, everything was all right. So if we close this, we are going to the latest part of this, because here it says the water balance. If you are here with me, please type yes 15. If for by some you have followed a tutorial to install MODFLOW 6, but here you will need MODFLOW 2005 install as well. Where is MODFLOW 2005 installed? You have to go to model program location if you have any program, and then you need MODFLOW 2005 here installed. You need to have this. As well as you have the MODFLOW 6 in white, you need to have MODFLOW 2005 in white, otherwise it won't run. Okay? Yeah, you can download it from here and do the process. It's really similar of the certain MODFLOW 6. Okay, so here we are, and this is our water balance. Okay, sorry. And here in our water balance, okay, yes, just follow us, and while later on you can install your MODFLOW 2005. Yeah, yeah. In our water balance, we have that the constant head brings 11 liters per second. No, in our case, 1 liter per second. Yeah. The wells do not take anything, and the river brings 1.28 liters per second, and from that, the wells takes most of that, takes like 90% of that, and just almost 1 liter per second goes to the, no, it takes almost 60% of that, and almost 1 liter per second goes out of the system, okay? And the frequency is really low, and then you have reached the conversion. And then what we are going to show you is the water heads. Okay. Okay. So we close this, and with this one, we are going to open the PhD. Okay. We are going to open the PhD. That are the head distribution, but as a binary file, as a control grid, and this is our. You can do more. Okay, I will repeat it. I will repeat everything from the from importing the file, but I will just to show you. Just please follow me because I will repeat. I can do this, and I can change the color scale. And then you can have this where you have your pumping, you have your river, and then you have your regional flow. Okay? Okay? So, and then I go. Okay, let's do all together. Okay, with that, I delete all my results, and then I can import it again. So let's go import and display more results. Let's open the PhD. Let's open as a contour grid. You have only one stress period, so there is no problem. Let's type OK. So you have this. Okay, maybe you have it in another colors. Okay, I want more contour layer because this is every meter, but I want more. So I can go here to data visualization, and here on data visualization, here on color data, the contour interval will be 0.2, and then I can change it from brown to blue. Any color scheme. Okay, and that's it. If you are here with me, type yes 16. Otherwise, I can repeat. Okay, if you are here with me, type yes 16. Otherwise, I can repeat. Okay, yeah, I mean, if you have any problem till here, just install. And this is mostly the work that you will do when you do numerical modeling. I mean, you have to be always looking, installing, working. It's very interactive. Okay, anybody else? Anybody else? Okay. Anybody else? Any questions? Okay. Well, uh, Hans, are you there?
Yes, I'm here.
Yeah, because there is a next step, there is an exercise on this class, and the next exercise is to import a digital elevation model into a MODFLOW geometry. Yeah. Um,
Yep.
this will take 20 minutes. It will be all right for the organization of this course.
Yeah, or do you have more time next time to do it?
So, what you do the material. What I can do is I can show the procedure, and then they will have the video,
I think
and
that's a good
they,
idea. Yeah, just show it,
yeah,
and then if there are questions, people can ask next time.
yeah, okay, and they will have the video in the end. Okay, so I just go here. Okay, okay. What we are going to do, I will going to show you to do it more quickly. The next exercise of the course, I will do it explaining all the details. However, for you, you will have the video, and then you have all the steps, and then you can reproduce by your own, and then you can drop your questions. I will drop my you can drop all your questions through the chat next time, yep, to give you support. Okay, so I can save this, but I prefer to save it to delete the results and save my project, okay? Okay, I think that many people struggle here. I strongly recommend to re-watch the video again. Okay, let's let's do this one, that is the big groundwater model, okay? I will do by my own, so just relax, just stay, just watch the video, because this is entirely work by my own. And then you will see somehow which is the speed of of a person that do this usually. I mean, production scale. Yeah, let's go here. Let's go to Model Muse, and then here we can do. We are going to work with ModFlow next. I don't need to next, and here we work with ModFlow NWT. Okay, you need on model program locations ModFlow NWT already installed. I mean, has to appear in white. It's the same procedure as the other ones. I mean, I have found that some of you say, okay, I couldn't find it, but this is not because I want this course to be incomplete, and I don't want to raise some question and say, hey, the teacher didn't haven't teach me that. It's mostly for to share the philosophy of dealing with this type of requirements. I mean, if you are going to do a successful career in groundwater modeling, or you want to do successful research in groundwater modeling, you have to be um, you you have to discover things by your own. I mean, half of the things, because there is also this course. Okay, so let's go ModFlow NWT 10.10.3 upper aquifer. So this is the same. Yeah, the same 100 100 finish. No, no grid. Let's go to no grid. Okay, so and this is my no grid, and then what I will do, I will open this from active zone shapefile. So file, import shapefile, file, import shapefile, and here on the data, on the day for, wait, okay, because I have downloaded the data from the course material. I have downloaded the data from the conf material, but I haven't extracted here. So, okay, so here's the data that has the active zone and some raster files and shape files. So here on data, I have active zone, and what it tells me is that says set value from closed cells and goes from 2, and this one goes from datasets required layer definition to model top, and then to the end of the model, that is lower aquifer bottom. Okay, that's amazing. Yes. Okay, nothing happens, and then let's go to model. Let's go to MODFLOW layer groups. Okay, and since we are working in MODFLOW to NWT, you have as well this. Your first layer could be convertible, your second layer could be convertible, okay, and your third layer will be confined, okay. However, here in the first layer, the discretization will be 5 because we are going to divide the first aquifer into 5 layers, okay. Uh, and the third layer will have also a discretization of 3. The first, the upper, and the lower aquifer will be split on 3, and this one on 3, while the rest will have a value of 1. Okay? Nothing will happen again because you cannot see the model because actually you have not generated your grid. So let's go again. So here let's go show or hide objects. And here let's go to unused objects and double click here to bring back the dialog box, this one. And then you use to set grid cell size of 50. Okay, this will be a 50. Okay, and here on data sets we define that inside this everything is true, so everything is active. Okay. If I type OK and I type close, and then if I generate this is my study area, but okay, so this is my study area, and inside this everything is active, but if I have some inactive parts. Okay, but the inactive parts in this case will come on a shapefile. So how do that? File, import shapefile, and then let's go to inactive, and then let's go here, set value to closed cells. It will be 2, and it will be called from model top, okay, to the end of the model, and then here, that's it, okay. And this part is inactive, as you can see here, this is this part. You can also select here on my use object because you have imported that you don't have applied to anything, so just do double click to bring back again the dialog box. You can check column, why not? And then here on datasets require hydrology active false because this part is inactive. Okay, false, and this type, okay. Okay, so and then if we change this to show active, you will see that the cells that are in this polygon won't be shown. Okay. And we are going to import a digital elevation model. Okay, so here you will see that we have 3 layers on the first layer and 3 layers on the third layer. Okay, but let's apply a surfer raster file. So file, import surfer grid file. So in GIS this is the GRD file. So and then on data we find the dem.grd. Okay, and then we apply these nearest points, cells by interpolation, and then we apply directly to model top. We can apply directly to model top, and we can point closest to cell center. Okay, this is a type of filter. Okay, And this actually brings the raster and apply directly to the cell. Okay. So if we type this, okay, and then we go to data to edit data sets. Here on layer on model top, we put interpolation fitted surface. You will find this. Okay, you will find this. Okay, okay. So let's work with the different layers. So let's go to data, edit global variables. Okay, no, edit datasets, data, edit datasets. And here we require it on layer definition. On upper prefer bottom, this will be model top minus 37.5. Okay, so the first layer will have a constant thickness of 37 meters. Okay, and this will be model top minus 45. Okay, and the last one will be model top minus 200. Okay, so this will be minus 37.5 minus 45 and minus 200. Okay, and the mod flow initial head is model top minus 10. Okay, and then on kx is 001, on kz is kx divided by 2, and then let's type apply, and then you will see, and then you have a lot of vertical acceleration. So in your view, vertical acceleration, just type it 5. Okay, so in your view, on your vertical acceleration, just type 5, and then you will see this procedure, and then you can watch which are the, okay, you can watch with as a color grid how are the elevations, the imported elevations in your model. So you can just have go to data sets, require layer definition, model top, and then you can use any. And this is the then file already inserted in the geometry of a groundwater flow model. And that's it. This was the second exercise of this class. And well, on Monday we are going to have our final class. For Monday, please be sure that here on plural locations you have all the executables, MODFLOW 6, MODFLOW 2005, and MODFLOW LWT, because as long as I know, there is no panorama when you are going to have one version that will oversee the other version. So I think that you will have an environment of 3 models, 3 versions of MODFLOW working all together. Okay, that was everything by me, Hans.
Yes, Saul, we also want to see you back, so maybe you can switch on your camera so we can close it off. I think this was a great session where we learned more about making our own models. And as Saul said, I think one of the important takeaways is that you really need to practice. We keep on repeating that, building your experience, and don't take these tutorials as a recipe to push certain buttons to get a fixed result that is applicable everywhere. Here is where your groundwater knowledge comes in, and you need to translate it to a model. And you see how many possibilities you have, how many choices you have in this tool, and that's all your choice. Furthermore, it was nice to see in the second half how to import GIS data sets. You see that MODFLOW supports a few formats, and some of them are probably GDAL supported formats. So there is on our open courseware website, where you also find this course, there is also courses on GIS. And one of the things that you really need to learn is to use GDAL. where you can convert between different formats and projections. The shortcut to go to that course is gisopencourseware.org. I will put it in the chat. And there you can find a tab on using command line and GDAL. And that is very important if you want to pre-process data for your models and for a lot of other things. So I'll keep it short, and I'm really thankful for good participation and for Saul for his clear explanation. The last part went fast, but the recording will be up there as soon as possible, so you can watch it back and repeat it. It's always good to repeat these things at your own pace. And I'm very curious about our last session on Monday. So I wish you all a very good weekend. Saul, some last words from you?
Okay, yeah. So as I told you, most come from practice, and then you have to repeat. You have the video to repeat, and then I think that the challenge is learning by the videos, and that is much more better than learning by the manual. I mean, I have learned from the manual, and I can tell you that from the videos. Yes, something really short. I have in our e-learning platform, we have a new event, and this is something new, that we have a new event on filling missing precipitation data with machine learning in Python and scikit-learn. We are going to develop this the next Friday. I think that is next Thursday, the 20th. We are going to develop this webinar. But this webinar is on open source software, but has a cost of $15. And just to remind that the payments is in order to support our research. Sometimes our webinars are free, and sometimes we charge for that. Well, we hope you can participate as well.
That sounds really useful, so I can recommend to do that. You need to treat your data before you can use it in a model. So this is also part of that knowledge that you can gain. Thanks for the tip. So very nice weekend, everybody. Have a good dinner, breakfast, lunch, wherever you are in the world, and see you back on Monday.
Okay, see you. Have a great weekend. Bye-bye. Bye.